Hello once again. Got a relatively easy task today. We're looking at electrolytic cells, and typically with an electrolytic cell, you will start with some kind of compound, like in this case sodium iodide, NaI. So you'll have a solid, some kind of mineral you dug out of the ground maybe, and you're thinking, I know there's sodium in this, and I know there's iodine in this, and I want to separate them. I don't want the combined sodium iodide. I want pure iodine that I can do something with, or I want pure sodium I can do something with. So we want to turn these from ions into their pure elements. And there's going to be two separate reactions for that. One of them will be sodium ions, which we want to turn into sodium metal. And the other one will be iodide ions, which we want to turn into elemental iodine. Now, if we're balancing these, there are two iodine atoms here, so we need two on the left. And the other thing we need to do to get these balanced is add electrons. There's no oxygen or hydrogen to speak of, so those steps are not relevant. But if we have +1 charge here and 0 here, then clearly sodium must be gaining 1 electron. And if we have -2 charge here and 0 here, then 2 electrons must have been released by the ions. So these are the two half reactions, and if we add these together, we would get our overall cell reaction. Oops, worst line ever. Okay, but we can't add these reactions because why? Right now their electrons don't match. This one is gaining 1 electron, this is losing 2, so if we double the sodium half reaction, have twice as much of everything. Now our electrons match, meaning we can cancel them, and the overall cell reaction would be 2Na plus 2I minus 2A plus I2. And if you calculated a cell voltage for this, it would come out negative, telling us that this reaction will not happen spontaneously. We would have to hook up a power supply and force it if we wanted it to happen. But it's still just a redox reaction. We balance them in the usual way. The only thing that's really different about these is that they have negative cell voltages, which doesn't change our procedure much at all. Okay, new thing. Calcium phosphide. Calcium produces +2 ions, and phosphorus produces -3 ions. This is going to be Ca3P2. Is what we're starting with. Although, do I even really need to write that? I guess not. I'll put it up because it's kind of automatic to write a formula when they give you something like this. But really, those ions are what we care about. When we start this, we're going to have calcium ions, which we hope to turn into calcium metal. And we're going to have phosphide ions. Sorry. Which we hope to turn into elemental phosphorus. Phosphorus is a little bit weird. There's a P4 version of it. There's also a P10. But P4 is the more common. So typically when people say phosphorus, they're talking about P4. And if we want to balance this for charge, well, first balance it for atoms. There are 4 phosphorus atoms here. We need a 4 there. Calcium's 1 to 1, so that's okay. And to balance this for charge, we need 2 electrons on the left side there. And here we have a total of -12 charge, so on the right here we're going to need 12 electrons for that to make sense. Again, we want to add these two half reactions, but we can't because 2 versus 12. So to get this to 12 electrons, I'm going to multiply the whole reaction by 6. We get 6 calcium. 6 times 2 is 12 electrons, and 6 calcium there. Now we can cancel the electrons, and our net reaction is going to be 6 calcium ions plus 4 nitride ions, produces 6 calcium metal and a single molecule of P4. Not too bad. Not too bad, I hope. Okay, aluminum nitride is made of aluminum ions, which are +3, and nitride ions, which are -3. So ALN is the symbol for the compound. And if we want to electrolyze that, we'd be taking aluminum ions, and we want to turn those into aluminum metal, and we want to take nitrogen ions, and turn them into elemental nitrogen, which is N2. 2 atoms here means I need 2 on that side. And if we're balancing charge, +3 versus 0, left side needs 3 electrons. -6 versus 0, right side needs 6 electrons. Now what? We want to add these together, but we can't because electrons don't match. So we double the aluminum. 2 times 3 is 6, and 2 there. Now we have equal numbers of electrons, which means we can cancel them out. And we get 2 aluminum ions plus 2 nitride ions produces 2 atoms of aluminum metal and 1 nitrogen molecule. Not too bad, I hope.